In this video, I'll show how to solve two equations in two unknowns using the solution by row operations. This method takes advantage of the fact that you may add the same quantity on both sides of an equation. So if I would like to add, say, some constant on both sides, let's draw that in green, constant k. As long as I do it on both sides, it's still a valid equation. Also, I may subtract k, of course, and I may multiply each side of the equation by the same number as long as it's not 0. Now, a special case of this rule is that I may add, say, my left-hand side of this equation to my left-hand side of this equation, as long as I add my right-hand side to the right-hand side of this equation. So how would that look? Well, let's try to do it. In this case, if I add these two equations, I would get 2x1 plus minus 3x1, that's minus 1x1, or just minus x1, and then 3x2 plus minus 4x2, that's minus 1x2. And over here on the right hand side I get 1 plus minus 2, that's minus 1. Now, I haven't really obtained anything from doing this operation. The purpose was just to show that this is a legal operation. I obtained a new equation, but I didn't really obtain any new information. But if I use this procedure in a clever manner, I'm able to isolate x1 and x2 and create two different and new equations in which each of these unknowns are isolated. So let's try to do it the clever way. So the clever way, here I have the same two equations over here, and the clever way to do this row operation is to multiply the first equation by some well-chosen number, so that when I add this equation to the second equation, then I will eliminate the first unknown in the equation. Now this may sound a little abstract, so let's just try to do it. So what I do is I take this first equation and I multiply it by 3/2. And what do I obtain by doing that? Well, I get, let's just write it in purple to stress the fact that I'm multiplying in all terms. That was the purple part, and then over here I get 2x1 plus 3x2 equals 1 over here. So now I have multiplied in all terms on the left side and all terms on the right side. So this is completely mathematically legal. So what I obtain is 3x1 plus 9/2 x2 equals 3/2. And now I'm ready to add this modified equation to the second equation over here, because now the first term of this equation will cancel out with the first term of this equation, and that's very fortunate for me. So let's try to add the two. 3x1 plus 9/2 x2 and 3 over 2. So we add these two equations, and what do we get? Well, the first term is easy. We get 0 x1, you might write. And up here we have minus 4x2. That's the same as 8 halves x2, minus 8, sorry, plus 9 halves. So that's just 1 half x2. And, well, this is minus 1 half. So let's try to keep track of what we've been doing so far. We have modified our original two equations into, well, we still have the first equation here, but now we've changed the second equation into this one. So what we have right now is this. And this is better than what we came from because we have a 0 here. So that means the x1 is eliminated from this second equation. Now I would like to eliminate x2 from the first equation. So I have to find a clever row operation that I can somehow modify this second equation and add it or subtract it from the first equation in order to make this x2 disappear from the first equation. And you may be able to see that what I need to do is to multiply this equation here by 6 and then subtract it from the first equation up here, because that would eliminate x2 from this equation. So let's try to do that. What I get when I multiply by 6 is 0x1 plus 3x2 equals minus 3. So this is the equation that I would like to subtract from the first equation. And what does that give me? Let me change the color here. Well, that gives me 2x1, because subtracting 0x1 doesn't make a difference, plus 0x2 equals, and then I get 1 minus 3, well, that's 4. So the equations I'm left with now in total are 2x1 plus 0x2 equals 4, and then 0x1 plus 1/2 x2 equals minus 2. And all I have to do now to reach the end of this is just to divide this equation by 2 and multiply this equation by 2, and that would give me 1x1 plus 0x2 equals 2, and 0x1 plus 1x2 equals minus 1. And of course I don't have to write this 0x2 and 0x1, but I keep the zeros just to stress the fact that what we have obtained here is sort of a system of equations in which there is, let me use another color here, there's a 1 here and a 1 here and a 0 here and a 0 here. So it's like this pattern here, and then we have some numbers over here. So we'll try to make this even more systematic, and to do that in the next video we'll look at 3 equations with 3 unknowns.